Hey seniors, welcome to our third and final day of benchmark review. We're going to cover repeating decimals today, comparing rational and irrational numbers, and adding, subtracting, and scientific notation, just to make sure that we are nice and crisp for our benchmark, which is next week. So excited, I know you guys are going to crush it. So let's go ahead and dive right in. Repeating decimals. Go ahead and draw your line in the top left-hand corner, write repeating decimals. I want to turn 0.27 repeating into a fraction. My first step is to set the value 0.27 repeating equal to x. Now, I see that there are two numbers repeating here, and that 7 is in the hundredths place. So my next step is to multiply both sides by 100. If there had only been one number repeating, I know I would have multiplied by 10, but there are two, so we do 100. 100 times x rather, is 100x, and then if I multiply 0.27 by 100, what I'm really doing is moving my decimal right 2 places. So I'm going to come out with 27.7. Then I take my old equation and I subtract it from my new equation. So 100x minus x equals 99x. And then 27.27 minus 0.27 will just give me 27. My last step is to solve for x. So I divide both sides by 99. And that gives me x equals 27/99. And then of course you know that this can be reduced down to 3/11. So 3/11 is my final answer. And remember, getting a fraction is the whole point of this exercise. Let's move on. All right, comparing rational and irrational numbers. In order to compare these, I know that they all have to be in the same form. And the easiest way to compare them is to turn them all to decimals. So that's what we're going to do. But I already see that -6 is a whole number. If I want to turn it into a decimal, I can just add a 0. If I have 1 and 1/2, if I want to turn that into a decimal, I know that I just bring down my large number and I do top in, bottom out with the fraction in order to turn it into a decimal. So I know that 2 doesn't go into 1, so I go ahead and put my 0. I know I have a decimal that I can bring up. I add a 0. 2 does go into 10 5 times. So 1 and 1/2 can be written as 1.5. Lastly, I have the square root of 81. If I want to turn this into a decimal, first of all, I need to figure out what the square root of 81 is. And I recall back to my weeks of practice that the square root of 81 is a perfect square and that it's 9. And if I want to turn this into a decimal, I can just add a 0. So I'm going to go ahead and list these from least to greatest because that is my final step in terms of comparing them. So that's what we're going to do. So I know that -6 is really small because it's negative, so that's our first number, followed by 1.5 and 9.0. There might be some cases where you have to identify these on number lines, and so that's where you just find these points on the number line, you put little dots, and then you mark what rational or irrational number was on top of it. Let's move on. All right, let's review adding and scientific notation. The biggest thing with adding and subtracting in scientific notation is that your exponents must be the same. Write that in your paper. All right, so let's move right in. Find the sum of 5.6 times 10 to the 4th and 1.4 times 10 to the 2nd. I know that sum always means add. Sum equals add. So I want you to go ahead and write that on your page. Sum equals add. All right, so I know that my problem is going to be addition. So I'm going to go ahead and write it out. My pen is your pen. All right, I can't add these yet because my coefficients are in the same form, but my exponents are not the same. So I can't add my coefficients until I get my exponents the same. So I know that I always keep the one with the larger exponent. So we're going to keep 5.6. But I need to change 1.4 so I can add my exponent. And I know that the way that I can add to my exponent is to move my decimal left, and this is where you remember your good friend Lars. So if I'm going to pull out my coefficient, I need to get 2 to 4. So I know I need to move my decimal to the left 2 places. Let's go ahead and do that. 1, 2, drop off my decimal, and now I have 0.014, and that allows me to add 2 to my exponent. So my new problem looks like this. 0.014 times 10 to the 4th. And then of course I have 5.6 times 10 to the 4th. My last step here, now that my exponents are the same, I can just add my coefficients. Let's go ahead and do that. Line up my decimals, always, always, always. Fill in my zeros. 4 plus 0 is 4. 1 plus 0 is 1. 6 plus 0 is 6. And then 5 plus 0 is 5. So I'm coming out with 5.614 times 10 to the 4th. Super easy if you remember that your exponents have to be the same. They absolutely have to be the same. Always remember your good friend Lars. Move on. All right. What is the difference between 8.3 times 10 to the 6th and 2.5 times 10 to the 6th? Difference always means subtract. Write this on your paper. Difference always means subtract. Always, always. So I'm going to go ahead and write out my problem. I have 8.3 times 10 to the 6th minus 2.5 times 10 to the 6th. And I go through the same process. Are my exponents the same? In this case, they are the same. So I don't need to change anything. All I need to do is subtract my coefficients. So I'm going to go ahead and do that. All right. I can't subtract 3 from 5, so I know I have to go next door and borrow and make 3 a 13. 13 minus 5 is 8. And then 7 minus 2 is 5. So I'm coming out with 5.8 times 10 to the 6th. Adding and subtracting in scientific notation is easy, easy, easy if your exponents are the same, and they must be the same. So always remember your good friend Lars. You're going to hear me say that for the rest of time. All right, seniors, that's it for review today. Let's go ahead and get into practice.